Today we're looking at special cases of solutions. The essential question is, what are the types of solutions to linear equations? Your learning intention. I'm learning to recognize the different types of solutions to linear equations. You have 2 warm-up questions. Pause the video and see if you can do the warm-up questions on your own. Well, I do hope you tried. If we're looking at the first one, I've taken x, I've multiplied by 2, then I added 3. The last thing I did was to add 3, so the first thing I do to undo that is to subtract 3 from both sides. 2x is now equal to 16. I've multiplied by 2. I need to divide by 2 to find x. And x is equal to 8. 16 divided by 2 is 8. Okay, on the next one, as we're looking at it, we've taken x, we've squared it, multiplied by 3, and then subtracted 5. What is my first step? I'm going to add 5 back to both sides. 3x squared is equal to 108. What do I do next? If you said divide by 3, you would be correct. $108 divided by 3, 36. So, x squared is equal to 36. The opposite of squaring is? The opposite of squaring is square rooting. Take the square root of both sides. And if we're looking for the square root of 6, not 6, 36. I'm looking at 36. It is 6 times 6. That's a perfect square. So x is equal to, now, there's always 2 square roots. There's the primary, which is positive, and the secondary, which is negative. So we do a plus or a minus 6. And we are done. Okay. Solve the following equations. Substitute different numbers in for x in the original equation. What do you notice? Okay, on the first one, we've got to distribute. So x plus 8 does not change. When I'm taking 2 and I'm multiplying by 0.5, that's the same as 2 times 1/2, and that gives me 1. So I've got x plus 2 times 4 is 8. So when I get ready to solve, I subtract x from both sides, and I end up with 8 is equal to 8. When does that happen? Well, it happens all the time. So let's put some different numbers in and see what happens. We're going to use numbers that are even because it will be easier to multiply by 0.5. So when x is equal to, give me an even number, let's say 4. 4 plus 8 is equal to 2 times 0.5 times 4 plus 4. Well, we know 4 plus 8 is 12, so I've got this side simplified. Parentheses first, 2 times. Okay, half of 4 is 2. 2 plus 4 is 6. 12 is equal to 12. Just like 8 is equal to 8, it happens all the time. Let's do one more number. Let's use a negative number. Let's use a negative 4. Negative 4 plus 8 is equal to 2 times 0.5 times negative 4 plus 4. Negative 4 plus 8 gives me 4, because 8 minus 4 is 4. 2 times. Okay, half of negative 4 is negative 2. Negative 2 plus 4 is positive 2. So 4 is equal to 4, and it happens. So, do you think it will matter what number we put in? No. So in this case, we will have an infinite number of solutions because what number we put in will not matter. If you want to keep working on it, put in different numbers. See if you ever get a solution that is not correct. Okay, on the next one, what's going to happen? I want you to notice up here, we had the same equation on both sides, which should have told you then and there, it doesn't matter what you put in, it will always be a true statement. So looking at the next one, once again, we've got to distribute. This time we've got two things to distribute. 3 times x is 3x, plus 3 times 4 is 12, is equal to 6 times 1/2 is 3x, plus 6. Take a minute and think about what's going to happen. What do you notice, and what will that tell us? Well, if I subtract 3x from both sides, I end up with the equation that 12 is equal to 6. Does that ever happen? No. If we can never get both sides to agree, do we have any solutions? No. Let's check it out though. If I let x be equal to 5, 3 times 5 plus 12 is equal to 3 times 5 plus 6. 15 plus 12 is equal to 15 plus 6. We can already see there's a big problem. Okay, 15 plus 12 would be 27. 15 plus 6 would be 21. They are not equal. You can never ever get a solution. So, if they're identical, you've got infinite solutions. If they have the same coefficient with the same variable, but different constants, you will never ever find a solution. Okay, for the last one, distribute. Five times x is 5x, minus 5 times 4 is 20, is equal to 3x minus 14. Okay, which is smaller, 5x or 3x? 3x is, so I will subtract 3x from both sides. I've eliminated it from the left side. 5x minus 3x is 2x, minus 20 is equal to negative 14. I need to get the 2x by itself. I've subtracted 20. I will now add 20 to both sides. 2x is equal to 20 plus negative 14. 20 minus 14 is 6. Divide both sides by 2. And x is equal to 3. How many solutions do I have? One solution. So as we're looking at this, there might be an infinite number of solutions, there might be no solution, or one solution. Those are the three types of solutions we find with linear equations. Okay, Bree simplifies an equation and gets 2 is equal to 3. What does that tell you about the equation? What does it tell you? It tells you there are no solutions to this equation. Okay. Now, when we get ready to determine, we actually try to solve the problem. Then we'll look at it and at what we get and determine if there's one, none, or infinite number of solutions. So as we solve the next one, we have to distribute. 9 times x is 9x, plus 9 times 5 is 45, equals 9x plus 20 plus 45 is 45. What do you notice? Both sides are the same. How many solutions? Infinite. Both sides are the same, so you're going to have an infinite number of solutions. Okay, I want you to pause and look at the next one and think about it. Get the idea in your head. Alex says that 3.2x plus minus 5 is equal to 3.2x times the quantity of x minus 5, and that it has infinitely many solutions. Is Alex correct? Explain. So think about it. If you can do it without doing any math, that's great. If not, make sure that you do the math. I hope you thought about it. I hope you have the answer. So 3x minus 5 is equal to 3.2x. I forgot that point 2, that pesky little thing. And this is in parentheses, so I've got to distribute. Okay, distribute the 3.2 both times. I'm going to come over here. 3.2 times 5. 2 times 5 is 10. Carry the 1. 5 times 3 is 15. Plus 1 is 16. I've got 1 decimal point. So I've got 3.2x minus 5 is equal to 3.2x minus 16. What do you notice and how do you use that information. The variable part is exactly the same. The number is not. If those numbers are not the same, we will never ever get a solution. So there is no solution. Because the variable terms are the same, but the constants are different. Now, we didn't really answer the question. It says, is Alex correct? Alex is not correct. Okay? How do you know when you're successful? You know you're successful when you can identify the number of solutions that an equation has. So, solutions. 1, none, and infinite. So, 1, none, and infinite. If you know how to determine them, that's really good. If not, go back through the video.